Hi, I'm Jack.
I'm Skylar.
I'm Kagan.
And I'm Brendan.
And we're Group E. Today we're going to present to you the results of our Advanced Energy Vehicle Design project.
This video will explain the general design process and the steps we took to achieve our goals.
This wind-powered vehicle project was based on a concept thought up by George Benny in the early 1930s. However, due to the rail company's bankruptcy, the project was unable to be created on a full scale. Our task is to implement our own successful version of the project. Our primary objective is to design an autonomous vehicle that will run and stop itself on a suspended track. The vehicle must stop within a specified area and attach itself to another cart to return to this marked station. We must create a design that will complete those tasks and do so in a way that highlights its energy efficiency.
The first step we took was to collectively brainstorm our ideas. We did this by individually hand-drawing various designs in orthographic views. Each member had to think of his own design, create a drawing, and explain the advantages and disadvantages of the design. This method of compiling concepts allowed each member to share their ideas in an equal way. When collaborating designs for a group project such as this, it is best to take all available ideas into account.
We determined the quality of each concept by creating a table which categorized each vehicle and its proficiency in subjects we thought were important to the overall design. Through a scoring system we had created, we decided on our third conceptual design. This design had heavy influence from Boeing's V-22 Osprey, which could rotate its engines and propellers to change the vector components of thrust. We decided on this design because the ability to physically change its thrust would slow the vehicle down efficiently rather than consuming additional energy to reverse the motor's polarity. Now that we knew the design that we wanted, we needed to figure out the necessary components required to carry out the project. In addition to the pieces provided to us by The Ohio State University, we decided we also needed electrical servo motors in order to rotate the wings as we desired. We also realized we needed to laser cut a custom body plate of our design so that the propellers would not hit the body of the vehicle.
After creating a prototype of our design, several tests had to be performed so that we could determine where the design was doing well and how it could be improved further. Some initial problems we ran into were getting the servos to rotate to the correct angles. The servos we had used were slightly inaccurate, but manual calibration to our microcontrollers resolved these issues. For example, instead of using 180 degrees for both wings, we would use 178 and 183 so that they would line up horizontally. Another recurring problem was getting our microcontroller to communicate to the computer. We ended up switching out the Arduinos with a new one that we had purchased. This resolved the communication errors we were receiving and allowed us to experiment with its features outside of class. Other than these few technical errors, our greatest challenge was to program the vehicle to activate its brakes at the correct moment and with the correct power. We began to notice a significant variance in performance as we made more runs. We figured that each run drained a portion of the battery, and so we decided to replace the battery every few runs.
Overall, the design of the vehicle was even more efficient than we had anticipated. The vehicle weighed only 268 grams and consumed only 43 joules of energy from the battery. The rotating wings did not place any unnecessary torques on the vehicle, and it behaved exceptionally. Our track run proved that it is efficient as well as accurate, with many of our runs landing right on the mark. Our hard work and innovation shows that it is incredibly feasible to take a concept and make it a reality. Hopefully, our design will spark newfound inspirations in transportation technology of the future.
This project has taught us the importance of the design process. It showed us that with an organized plan, it is easy to reach your objective. Hard work and teamwork have proved yet again to be the most useful attribute in such an assignment. To be successful in future endeavors, we will apply the same process to our occupations to hopefully yield the same results.
I'm Brandon.
I'm Kagan.
I'm Skylar.
And I'm Jack.
This is Group E, signing off.